controversial subjects with the facts can be tense, but we are a sub-science here to make things make sense.
So,
Mushroom computers.
yeah, we're getting out of our goddamn wheelhouse today because we're going to be talking about binary code. It's like,
And
what?
when you first pitched this, I was like, no.
It's hard. It's confusing.
To be honest, that's why I was like, I don't know. Sometimes when it comes to like computing and quantum physics or mechanics or anything like computing, I get overwhelmed, but it is very interesting. I just wanted to say this out front, hopefully, so that you stick around if you also find this topic overwhelming.
No, I disagree. I think quantum mechanics.
You think it's not interesting?
No, I'm saying I think quantum mechanics and quantum physics is like the most interesting, coolest thing in the world. I think computing is where I'm like, I go cross-eyed and it's really confusing.
Okay.
All interesting, obviously, but like I don't think people think quantum physics is boring. I think most people are like, this
I
is the
didn't say
coolest thing in
boring.
the
I
world.
said overwhelming and just like difficult when I'm like, I feel stupid researching it. And I'm like, yeah, that's all. But I also find sort of like the future of technology to be an interesting conversation. Sometimes I think it's like, I don't know if like, what's the right term? Like sometimes I'm cynical and I'm like, this is also stupid and meaningless. Like, what's the point? But then other times I'm like, no, actually, it's really exciting. Like, not that I'm talking about like, what's the next phone going to be? But just it's cool to think about what the world might look like in 20 years in terms of technology.
Yeah, well, this is just essentially talking about computers that might leave binary code of zeros and ones, which, yeah, don't ask us what that even means. But all computers are based around the concept of like binary code, but quantum computing and mushroom computing are trying to get away from that. And then in theory can process way more information more quickly and potentially solve things like climate change by like making lithium batteries work better or like creating new substances that can create like ammonia out of nowhere, or like a COVID vaccine could be made like in days because you just like actually process information so much quicker is the reason why like your governments and Google are spending like millions and billions of dollars on quantum computing, even though it doesn't really like exist yet or work.
Can I go on a little bit of a side note? Because you were talking about like, you know, like cracking a code, right? Like a lot of times computers are running algorithms to figure things out or to run, what do you say? Like, what's it called when you like run a, I don't know. I don't know.
I'm like, you're up a creek without a paddle
my
on
brain
this
does
one.
this. You know what I'm talking about. When
I
the
don't.
computer like runs a simulation.
Algorithm?
That's the word.
Okay,
okay.
okay.
I'll try and make this a short side note, but I was talking to someone recently who is like a legal, like a, what is it called when you're like a crown prosecutor? You know who I'm talking about. It's somebody that we met recently. Basically, they were explaining to me that in a case where like they're prosecuting somebody and they need access to their phone, for example. I know this is like sort of obvious in a way, but he was like, obviously the person, if they're like worried about being guilty or like they don't want to give over their passwords to their things, he's like, literally they will have to start computers that are just like running every single like combination of passwords to try and crack open their devices. And he's like, so sometimes that can just like take forever until we're actually able to like get into their phone and like look at their stuff. You know, like they have a warrant to do this.
Yeah,
And
I'm like, that's cool, but also I'm like, who is this? I didn't know who you're talking about.
when we were at the wedding,
There was a
like his
crown
cousin, yeah,
prosecutor there.
yeah, from Canada.
Oh my!
We can talk about it later.
God,
I'm not
I
like
should have
nothing secret.
shadowed-
I just don't want to like say people's identities
That's
on the
so
show.
cool,
but,
though. I didn't know that.
yeah, no, it was like really fascinating, and I thought that was so interesting, and it made me think about, you know, he's gonna hopefully be like, yeah, mushroom computers, because they'll probably crack that code faster.
I think it's going to be the quantum ones, but yeah. Well,
okay.
That's the idea around this, is that quantum computing, if it goes ahead the way that they think it could, that means that essentially all your text and all your information is encrypted in a way to be safe online, that a quantum computer could like crack it like so quickly. That's why these countries, and there's like, you know, the classic like China versus America, who's going to get there first? Because whoever does could essentially like breach all the classified information like easily.
Right.
So that's like the risk around quantum computing, is that
Right.
if these computers actually do what they're supposed to do and do what people think they could do, then you have to rebuild all the systems from scratch to be safe again.
Yeah, but
which is kinda crazy.
and that is what is always happening, though, right? It's like it literally mimics evolution. It's like when one security gets better, then like a hacker's abilities have to increase. And then when the hacker's abilities increase, security has to get better. And in evolution, you see animals that like get better defenses and then better other animals that get better offensives. And then
It's just like so weird that it has to do with zeros and ones in math.
yeah.
But okay, classical computers use bits, which take the values of 0 and 1. Again, I go cross-eyed fall over. But today, we see problems with binaries. Like 0 and 1 represent the traditional approach, but like most dynamics in the real world aren't captured like through that system. Like it's not a very like intelligent way to, for example, mimic biological pathways by using these like things. So quantum computing could be better at simulating like molecules in real life problems because quantum computers use qubits, which can take the value.
Can you spell that? Qubits?
Qubits.
Cute. Okay.
Quantum.
Cute with a Q.
Like, yeah, it's, you know what I mean? It's because of quantum.
Yeah. Okay.
So they can take the value of 0 or 1 and also a complex combination of 0 and 1 at the same time. So I know.
We all die.
I know.
Okay, so like whatever that means.
Okay,
but it
so
just
like
means they can do more.
Okay, so it's kind of crazy because like the coolest thing about physics and why I'm obsessed with it, even though it is the hardest course, and when I think about my physics classes, I did cry in the exam, is that like they can study this and they can build theories, but like they don't know what's going on for sure. We're still in such a place where there's so much to know about physics, but you can still talk about it and be like, this is what's happening.
Right, but we don't quite actually know why it's happening.
Yeah, because when
that's cool though.
When you start to hear about this stuff, you're going to be like, they're lying.
It's magic.
Yeah, okay. So quantum mechanics is the study of matter and its interactions with energy, but on the scale of atomic and subatomic particles. So like you exist in the macroscopic world where you're touching like a sofa. And like you can see it and things are big. Like we're talking small ass particles, subatomic particles.
Like the smallest constituents of atoms, basically.
Yeah, and they live in like the quantum scaled world where we're building all these like models around them. So it's smaller than atoms. We're talking electrons.
Crazy? Like yeah, no,
Smaller
sorry.
than atoms.
I'm just saying
Atoms are big.
Most people's reference point is like the atom, which I'm pretty sure comes from a Latin word which means like indivisible. So irony. But you know, we keep realizing like there's smaller and smaller and smaller things. And that is also partially related, like if you heard of like the Higgs boson. It's like a really tiny thing that they spent so much time trying to prove was actually real by smashing other particles into each other. And they've only could like see it for a flash of a second, but then they were like, it's there.
Yeah, they know. That's what's cool. They have all these like calculations and they can figure it out based on like the laws of nature, but they can't measure it, which is also so freaking cool. And this is where you're going to start being like, you're lying, but we're not. But electrons behave like particles and like waves, like wavelengths. And that's something you learn kind of in grade 9 and 10 biology. I remember one of the first times I was like, you lost me, sir. And then like they, you know, it's like, it truly changed my whole life. I remember exactly where I was when I found out an electron was a particle and a wave. And I was actually like, I'm going to be into this for the rest of my life. Because in other classes, they're like, I don't know. Was Romeo in a good mood? And you're like, this is dumb. But then when you go there, they're like, hey, we're going to actually tell you that.
And we're going to like show you experiments that prove it.
And then
and blow your mind and
you're
make
like,
you seem like it's impossible. And yet here's the evidence.
Yeah, and you're
true.
like, wait, I'm actually learning about how the goddamn world works in this class. Okay, maybe this is maybe the coolest one. Okay, anyways.
Every like art student's slamming their fucking
Well, I also have
right
an
now.
art degree, which
yeah,
I
no,
do
I think
love.
it's important to understand that there's two sides to every coin, but there's lots of sides to a dice. And all I mean by that is you can explore and experience and learn about the world through all different facets. And science is one of them, and physics is one of them. But art is a beautiful way, consciously and socially, to explore the world, I think.
Yes, and
in defense of art.
I'm going on a side note because I walked by OCAD because I was buying my paintbrushes yesterday, where all the art students go in Toronto, and I was like, yeah, everyone here looks cool. You know, you walked by the STEM building, and it's like, you don't look cool. So there's like, you know, there's like, it's like these people they know something, they're reading something, they have a vibe. Know what you can't study with quantum physics? Vibes. Okay.
One day.
So
vibrations, though, on the other hand.
That's true. So
is that what a vibe is based off? Wow. He's got a cool vibration.
Yeah, that's actually a cooler way to say it.
Yeah.
Okay. So back to electrons. So they behave like particles in like waves, but the issue is all about like when you measure things. Oh God. Okay. So when you measure,
I'm gonna say like no matter what you're gonna say it slow because I'm
Okay.
already like focusing so hard.
Okay,
'Cause I'm,
okay,
like,
okay, okay,
Just for
okay.
everyone, especially because I can see you, but for people who can't, like, we gotta go slow here.
okay. So quantum mechanics,
Okay, it's faster than that.
prior to measuring something, you describe the states of, say, an electron based on probabilities.
Okay.
But the second that you measure it, it's no longer existing as a probability, and it is like essentially like solidified in a place, and it is no longer existing the way it was before you measured it. And so that is just like a fundamental law of nature, which is very confusing. It's Schrodinger's cat. Like you've heard of that before.
Right.
It's like that's
Before you look at the cat, it is in both a state of alive and dead.
Yes,
And,
and
once you look at it, that's where that like collapses on itself into an actual result.
yes, and it's just hard to grasp and to accept that reality is based on these like things. But this is again on a level that's so small, the quantum level, and we're still learning so much. Quantum entanglement is this crazy concept that like an example is like you and your friend flip two entangled quarters.
Okay.
So without looking at the results, the outcome of the coin flips will be determined only when you look at the coins. And it's like if you inspect your quarter and it comes at heads, your friend's quarter will automatically be tails.
You're topic. Okay, this is like
A metaphor.
a different. Okay, I was like, obviously that's not true. But if this was a quantum,
If it was a quantumly
world,
entangled coin,
they
and that
are equal and opposite in that way.
and people think that the result of like you looking at the coin, for example, and the other person's being tails and yours being head travels faster than light. And
Yeah,
it could be
right.
as far away in the
Instantaneous, right?
universe. It
Yeah.
could be like the entangled particle is like on the moon, you're on Earth, you look at yours, its heads, immediately the one on the moon is tails.
I love though that you're like as far away in the universe, and then you're like the moon.
Well, I didn't want to like, I don't know, be like, I don't know, like Galaxy X12, or like that doesn't even matter. I don't even know if that exists. And it holds true no matter how far away each of these things are. And it's kind of like, okay, what the hell? And like people don't really know why. And it was like, there was through all this math, Einstein literally was like, I think this is happening. I don't know. It couldn't be. That doesn't make sense in reality. And then like all these truly crazy people who've been considered crazy recently, people are like, okay, there are these things called quantum entanglement, and it's like so freaking weird. So anyways, quantum computing, it's like, you know how there's like zeros and ones, as I was saying, like, and they're binary code.
Yeah.
It is like there's a world where like the 0 and 1, they can exist on a variation between those
Okay.
until they're actually like studied.
Okay.
But it's like you can essentially work within the quantum realm of things to then process information in different ways. So there's like a Google like AI processor called Sycamore, which, okay, so the other thing is superconductivity,
Okay.
which is like essentially that at insanely cold temperatures, resistance to electricity can disappear.
Right.
So in order for quantum computers to use qubits, which can take the value of 0 or 1 or like a combination of both, they need to be in like superconductive states. So like this giant...
So the information can transfer really fast because
Yes.
there's so much of it or something?
Yes, it's like it has something to do. I don't really know, but they need the electricity to not have the resistance that like normal electricity does in order to do this. So all of this takes place in like a freaking giant cooler, which is why we need helium. Also, like everyone's like, we
Which
need
is
helium.
running
'cause
out.
helium. Yeah. It's like, yeah, good luck if there's no. Oh my God, it is so confusing.
So all this though to like say what?
Okay, so it's to say that it's like in that weird world of like when you think about flipping heads or tails, that's the binary, right? Like there's like a head, there's a tail, there's a 0, there's a 1.
Yeah.
If they can work in the world where there's like that like middle space where they haven't measured the thing yet and it's existing as all the things, essentially they can process. They can build complete, the thing is they'd have to build new hardware, new software, new complete programs that are no longer existing with 0 and 1s, but are existing with 0, 1s and everything in between. And for whatever reason, which I cannot explain to you, the processing power of information of that is so large, it becomes this quantum computer that essentially everything a computer can now like we currently do that's really fast, it can do at
Like in split
exponentially higher
seconds.
values.
Okay.
Issues are, for example, these things aren't good at counting to 10. Like there's like
What?
there's like obvious things. Yeah, like
why?
that is
Because it's like I gotta count every decimal in between.
yeah, exactly. Because they're like, we're on the quantum scale, my friend. Again, it's just insane. Like there's so many reasons why this could be the thing I talked about a few weeks ago with driverless cars, where we never get the quantum computer.
Got it.
But
yeah.
if you do, everything has changed to the point that they're now calling it Y2Q as opposed to Y2K. They're like
it's the century of quantum.
like
Is that what that means?
They were like Y2K. We knew the date was coming. Y2Q, we have no idea when it's going to happen, but whenever these quantum computers start working, everything is going to be messed up in our
like that
tech.
will be
It could be a
groundbreaking
date in
point where
history
people look
books.
back to be
Yes.
like that change.
They're going to call it
the
Y2Q
world.
because Y2K, and then now it's Y2Q for quantum. Like
So
everything will
is
change.
there like a singularity like that? Like there's a point at which one day it will just work?
Okay,
or is
so-
this like a gradual, like we can make it a bit better at each day?
Yeah, it can be made a bit better. Like when you think about like processing information, these things, say they go like through a series of calculations. Like this is an example, but it's not real. But it's like going through 0 to 1,000 different like algorithms, or calculations, like really fast. Right now, when they're trying to get it to do 1,000, it'll make like a bunch of mistakes, like 3 mistakes.
Okay.
But every time they're getting closer and closer to it, no longer making mistakes. And then it's like once it starts to do that, there will be simpler problems. Like, for example, making the medication like Paxlovid for COVID. That took a lot of computing power and all these different things. Like they could maybe like give that problem to a quantum computer that could do it. Once it can get to like a certain amount of like computations without making a mistake, it could do that in like 10 minutes. But it's still at a point where it's making too
That's
many
crazy.
mistakes to really give it like
Yeah.
the complex things that would change the world. Like, and there is a world where these people are saying it will solve climate change. Like we will figure
Because
out
what the computer will be able to figure out what to do.
it'll be like, it will be able to figure out problems like how do we make lithium batteries like 10,000 times more efficient so we don't need to keep mining this much lithium.
Right.
Or-
but didn't you also say that the computing power required so high? Like, won't that also use so much more energy?
No, that was helium. I was said helium. This is lithium. But I'm saying like
No, but you just said in general that quantum computing takes so much energy, right?
oh yeah, no, but it's more saying like, okay, we're running out of food. We're running out of phosphorus. How do you make phosphorus synthetically? It could like figure these things out. That like hopefully according to the laws of nature that's possible. It's about solving problems about efficiency around climate change. It's not about like or like creating a model of like what happens if we actually like put all the like particles in the air and block the sun.
Right. You could just run like way more simulations to figure out like better solutions for things.
Yes, in
ultimately?
theory, according to quantum physicists who like I picture with like hairs everywhere, like and with like notebooks scribbling down things, and I'm like, I hope you're right.
Yeah.
Okay, so mushrooms, similarly, they're studying in like a computer type of way because they have like essentially like axons, like they kind of work the way our nervous system does, where there's like spikes and no spikes, and they like have action potentials is how they communicate. And they're like, maybe if like the spike is the 1 and the no spike is the 0, there's ways that we could use the information of mushrooms, which is like a completely different way of looking at things, in order to also have more understanding around biological or complex pathways to build these computers that don't exist in the 0 and 1s and can have also figure out things in different ways. So they're kind of like, these ones are not nearly as advanced as quantum computing, but it's interesting how people are trying to get away from 0s and 1s in binary code to try and essentially tackle the issues and the complexities of our world in like a different technological way.
Yeah, that's really cool. The only thing that's making me think that's a bit of a side note is, actually, I'm not going to go there. No, I think it's really cool. It is like a little beyond what I understand. And it would be interesting to talk to like somebody who is in the midst of this, but also then you're like, would it also still just be so confusing? Because sometimes even when I like talk to someone who's like a smart physicist, it really
Yeah,
is
they
like,
can't- yeah.
I don't know what the fuck you're saying.
Well, the entanglement thing, when it's just like there's entangled particles that that exist as both, but once you look at one, the other one becomes the binary other. I'm like, that isn't like, you can't make that make sense to someone unless they're a quantum physicist who must understand.
Yeah,
It just sounds
and
like you're
there's
making something
even
up.
even like more simple ideas of like the universe is expanding, but not into anything.
Yes,
Because
yeah.
everyone kind of goes like, where's the universe expanding? Like, what is it expanding into? Does it exist as like a sphere that's getting bigger? And then like a really smart physicist is like, well, no, it's just expanding
I
everywhere
know, and then
everywhere.
they obviously can understand that, but you're like, okay, well then I'm just gonna go back to eating my sandwich because I'm like, there's nothing here for me.
Yeah, and there's no way to like visualize. That's like
Yeah.
what I think becomes the hardest when you're a really smart person who studies things, you rely on just like math and numbers to describe things that otherwise are nearly impossible to visualize or make metaphors of that accurately depict what is going on.
And people will still try. Like I remember the first time I kind of started to understand quantum mechanics. My mom took me to this really cool movie called What the Bleep Do We Know? And I was like, my mom rules, because that movie was like, no one was in the theaters, and it was like kind of just a fun movie about quantum mechanics that made me obsessed with science. Go watch it. Maybe I should watch it again. But it was like, in quantum mechanics, like it dictates that particles like assume fixed values only once they're measured. Before that, particles exist in a superposition of many states all at once, described by probabilities. And remember when you would, like in grade 10, have to look at the visual diagrams of as you add electrons to molecules, they'd have those different okay, there was the simple rings, which is how it starts, which is so mean to kids, where you're like, ring 1, ring 2, and then you like draw on the electrons, and it's like, that's all a lie. There's like these other ones where it'd be like X, Y, Z, and it would show you like almost bubbles around each, and that was like the probability of
that was
where,
in grade 10, wasn't it?
again, TDSB Toronto, I don't know what's going on in the Catholic schools.
Oh my God.
But like they would show, didn't you say you showed up to university and were like, I was not prepared for this?
For some of it, yeah. It was like, why do all these people know this stuff already? I was not taught this.
Okay,
And
so
everyone-
maybe
on day one when they're like, yeah, so all the basics you should have had. And everyone's just nodding their head. And I'm like, what the fuck? I've never heard these words.
well, in Catholic school, they're like, they're shoveling you into religion course when you could be in the science course.
Oh my God.
Okay, so there would be these bubbles. It would be like X, Y, Z axis, and it would
Yeah,
show
like
you
probabilities.
like almost like the visual probability of where the electron would be.
Mm-hmm.
And I remember that was the first time I was like, wait, what? We're not talking about rings anymore. You lied to me. Second of all, what the hell? And then the teacher being like, and only once that is measured does that electron essentially end up in the space where it is when measured. And it's like, that's crazy. Prior to it being measured, it is existing as a series of probabilities of where it could be in what's known as a superposition.
See,
That's
so something that
insane.
confused me, because sometimes I thought, I just don't want to sound stupid right now, but
And someone might be like, everything Greg's saying is absolutely
yeah, because I
wrong,
thought that
but-
part of that was because the tools we use to measure the thing impact it. It's like that sometimes when we're trying to look at a very small, like whether it's an electron or something smaller, you have to use like light or something to see it. And by using that, you're impacting where it is in order to see it.
But that could also
That may also be
that
true.
can still be true.
But that's where I'm getting confused of like, oh wow, so yeah, like the superposition of it
but still,
actually being anywhere and everywhere until you look at it, and then it chooses, like, actually so confusing to me.
But that's what you're saying is still can be true. It's prior to looking at it. Where is it? Mm-hmm. According to calculations, it exists as a series of probabilities.
Right.
It's
and
not
so that's
in a fixed position. It's a
that's where I
superposition.
get lost, because I'm like, does it actually exist in all those places, or is that just why we can't know?
But that's why it's called like quantum mechanics, and why people are still trying to but they're trying to be like, it the crazy part that doesn't make you think it exists in reality is because it's like, how can that be? Mm-hmm. But they're like, according to our calculations, it is.
Right.
And that's why I think this is so fascinating, because it's like actually the most fundamentally small reason how everything works, like quantum mechanics and physics, is actually how everything works on the smallest scale, and it doesn't really register with the reality that we like see with our eyes.
Yeah, at the macro
and
level.
that's just something you have to accept, that like life is unbelievable.
Yeah, it is.
Oh my god, it honestly makes me like, it's the coolest shit in the world.
That is a weird thing you have to come to terms with, that like things at our scale, because you just kind of think everything's relative. Like if you blow things up huge or if you shrink things down small, they follow the same like laws, and a lot of things just fall apart. That's like where the line of quantum is, where like it doesn't actually follow the same laws of quote unquote nature anymore that we would know at our regular like scale.
Well, it's also frustrating when you're taught, like everyone's taught the periodic table with the rings and the electrons. Like you start simple. Yeah. And it is annoying that eventually it's like, kidding. Like, you know what I mean? Like, it would be really cool if you zoomed in and there was like this little thing that you could see that was spinning with like a little electron. Even the way they show it going like around the atom. I'm like, oh, that actually makes sense. That's cool. But it's like, that's just how you have to start people's knowledge of this like incredibly complicated and fascinating stuff that is the most important stuff in the world in like some senses. So the issues with like what this computers could do if they can figure this out is that like bank transactions, text messaging is protected by cryptographic keys that conventional computers would take years to decipher, but a quantum computer could crack them in less than like a day. So you can essentially crack into like that guy or that prosecutor would get into that phone real quick. And so it just changes everything. It changes like cybersecurity, all the weird things people talk about all the time. Yeah. Is part of the reason why like these companies are spending so much money on something, which as we just discussed, theoretically doesn't even like make that much sense. Because the actual outcomes of this could be so big on like
just change. It's just like a seismic shift in technology. I feel like my brain's melting, and I don't know if I'm just like having an off day or like I'm like, oh my god, I don't know what to say, you know. Well, I feel like that. I just feel like stupid, or I'm just tired.
No. I also think it's just like it's not really fathomable for people like us. We can't understand it. We just have to understand it through weird ass metaphors and information.
I think it's challenging too, because I want to have somebody who, like, not that you are not like you're not an expert.
No, I'm not an expert.
So I don't want to just like keep posing more and more questions to you, because I'm like, well, we don't know the answers.
Yeah.
That it would be interesting to have somebody who like could confidently say like, yes, I know so much about this that I could at least tell you when I don't know the answer versus when I do. So
but
that we could just be like,
I would just say no.
No, I don't have any specific questions, but I just sort of feel like my brain's all over the place and I just want to ask things, but I'm like, I don't know. I don't want you to feel like you're having to make up answers or something.
No, but I wouldn't. I would just be like, I don't know.
I don't even know if the thing I brought is that interesting. I can probably say it in like 10 seconds, but it's about mushrooms and computers.
No, I'm going to go off.
So it's just like another interesting way that mushrooms are now being proposed to integrate with computers, and that is for sustainability. So it's like usually electronic circuits are made of, like, they have to be in a substrate that's usually made of like plastic polymers, and so that ends up producing so much waste when like a microchip or a circuit has to be thrown out at the end of its life, and it says it's like contributes to 50 million tons of electronic waste per year. So in this new research that I came across from, I think 2022, they dried out skin from mushrooms, Ganoderma lucidarum.
One of my faves.
To act as that substrate where all like the electronics would go on, basically. Typically it just grows on decaying wood. And so they found, like, when it's dried out, it's super flexible. It's a good insulator. It can withstand temperatures of more than 200 degrees Celsius and has a pretty similar thickness to that of a sheet of paper. And so it like fits the bill for those plastic substrates.
I mean, that makes sense. Yeah.
And it says it could last for hundreds of years if kept away from UV and light, but it decomposes in 2 weeks in soil. So they're like,
don't go work in a park with your laptop.
No, it's not that. I mean, it's just saying like it's so that when they dispose of it, it would break down in a good way.
Though, you're like, I got my new mushroom Mac computer. You go to, you like put it down on the grass,
get some dirt.
You're like, the bottom decomposed.
And so they conduct just as well, and it says it remains effective even after bending more than 2,000 times. So they're just proposing like this could be a great alternative to the amount of waste we produce from like this plastic on circuits coming from mushrooms.
Yeah, the thing I was reading about too was like slime mold computers. Like essentially slime molds are intelligent in the sense that they can. Slime molds are not mushrooms, by the way, even though The Last of Us wants you to think they are. But
they are a form of fungus.
Yeah,
right?
But they're the Last of Us mushrooms.
Well, you said
me
like
about to say something so aren't real. It's like, yeah, we know. It like anyways.
We already talked about this. It was
Yeah.
just how like the slime mold is what the intro looks more like.
Yes,
but
yes.
they're talking about something else in
Yeah.
the show that doesn't like
Not
track
quarter
with that.
But they're intelligent in the sense that they can find the shortest path through a maze without programmers giving any instructions or parameters. And so they think that slime molds could be better. Like slime mold computing could be better at like figuring out like traffic issues and things that other computers aren't that good at. Also, like the idea of a mushroom computer is called like wetware, where it's like you use like biological and chemical, even quantum mechanical systems are a form of wetware in the sense that it's based in like biology and nature. The computers rather than hardware and software, which is like what we've made up. It's almost like synthetic versus like natural.
Yeah, okay.
And weirdly, quantum is kind of natural because it's
Really?
it's basing around like the nature, the laws of nature, the way we.
But they're like
understand them.
still using like hardware, aren't they?
Yes, but the actual like concept isn't just like a made up thing that they did of zeros and ones. It's like based around.
But okay, this is what I was gonna bring up earlier, and I'm gonna try and make it short. It will be, but I'm just like, because that 0 and 1 philosophy also runs through a lot of like spiritual philosophy of how like everything has an equal and opposite, and that it's like kind of natural for there to be like these two sides of everything. Like, I don't know, like there's night and day. There's like in order to experience happiness, there has to be sadness. Like everything has a binary. Doesn't mean like life is made of binaries, but that like in order to see something in the foreground, you have to have a background. Like those two things, there's always this like yin and yang.
Except we don't believe in gender binaries on this podcast. Kidding.
No, it's not like, I'm not even saying that. It's just how like.
But what do you mean, like from a philosophical perspective?
Yeah, like the idea of yin and yang is like everything is like a complete form of like one thing. They're all in
is
a
that
philosophical.
what 0 and 1 is? I guess
In a
it
way,
could
it's
be.
not literally that, but it kind of mimics that. And I think at least, but I may just be thinking on like a level that's not like actually related to what it actually is. But there's something about, maybe I just don't understand the quantum part well enough to see where it fits into that philosophy.
That makes you feel like it's breaking that somehow or something.
Yeah, or that I don't know. I guess like in my mind, it's more understandable that things can be broken down into kind of like on and off.
Yes, like
and a combinations of on and off, right?
Yeah,
because even like
totally.
Sound is a combination of sound and silence. It's like literally things like
and energy,
coughs
and energy is a wavelength,
peaks, right? So it's like up and down, on and off, on and off at different ways into your ear.
Yeah, no,
that computes into sound.
That makes sense.
Same with light. It's like beams coming on and off, like in a waveform, right?
Well, but then there's photons.
Yeah, okay, but
that's a good example is light, right? It can behave as a wavelength and a particle depending on what it's doing and how it's measured.
Yeah, but when you're seeing light, isn't it a wave?
Yeah, but there still are photons. Like there still is like, it is maybe like quantum. What you're saying is really interesting because it's true. I actually like, not that I've ever understood computing at all, but the idea of being like yes or no,
like
one
distilling
or zero,
it down
like,
to the smallest form of like on or off,
like
and then
your neurons,
combinations
like
of ons and
potential,
offs
like,
is what so much biology seems to actually be.
Yeah.
Like exactly, like neurons, like just turning on and off in crazy successions can create really complex patterns.
Or like sodium going through a sodium ion channel literally is
opening
an action
and close,
potential.
open and close, right?
Yeah.
So it maybe with the quantum stuff, I'm just maybe at a smaller level, it is still kind of doing that, just at a way bigger scale. I don't know.
And that is why it's like we need to talk to someone who actually knows, because it sounds like that is a really like normal instinct to have, and this is where these things are falling apart, is at the quantum level, and where there's just so much more information and energy and places to essentially like crack the future of like understanding how physics actually works.
Yeah.
Because we're now so
and it could be a
intelligent that we're
seismic
getting that.
consciousness shift too. If something like that happens, it might also change the way we think about the world and the universe and time. And
I
all
think
these
that's why
things.
everyone's talking about it, because it's like it will change everything. Just in the same way, like there was a time where people were like, there's microorganisms. That does change everything.
Yeah.
Spirituality changed. The concept of life changed.
Yeah.
Religion plummeted. Like these things, like they were like, oh, the plague wasn't a demon. Like, you know what I mean? Like it's
Right.
like that is
You really
the reality
see the
of life
world
that.
in a totally different way.
So I feel like cracking these quantum mechanical questions, there will be a fundamental frame shift if it can be articulated to people properly.
Right.
Which I don't know. I don't even know if I did a very good job, but it was just like I was just reading a bunch of shit about it all week and just like being like, parts of this are so interesting to me, but they're just words and metaphors. And like quantum entanglement is at a certain point, I think, just a metaphor for even the people studying it. Because they're just like, we don't know why when we observe something here, a entangled particle as far away travels fast in light to be the opposite.
See, I need to know how they know that. Like, how do they know it can be at the other side of the universe?
Yeah. And the crazy thing is, like, Einstein literally figured out in a math calculation, and then
he's crazy.
Yeah,
man.
everyone was just like, "That's insane," because that doesn't.
And just like
sense.
so long later, where they're like, "How did he already get all this?
Yeah, it's like
why hasn't there been another one of him?"
No, I know, and it's like it's not just like the simple ones we all know. It's like crazy shit.
Even stuff that at the time they're like, "Well, he got that wrong," and now they're like, "Wait, maybe we should have looked at his notes more."
It's like hot take. Do you know Einstein's really smart? Okay, we'll keep talking about this because I just want to keep reading more and more.
Someone out there who is a quantum physicist.
Yes, we would
Come
love
on
to
the
have you
pod.
on because we want to ask questions.
Yeah, I just want to like ramble about it and sound stupid and not feel scared to ask dumb questions because then we'll at least get answers.
Yeah.
That will be helpful.
Yeah. And
I don't know. I feel so weird.
And
today.
sometimes it takes like dumb people like us and like normal people to like ask the questions that make quantum physicists be like, wait, oh.
Imagine we help them crack the code.
No, but I mean like sometimes
to explain it. Yeah.
Like it's so smart to go into like grade 3 classes and like try and defend your thesis.
Right.
Because I honestly feel like
to practice breaking it down in simple terms to the average person.
Yeah, for sure. That's how ASAP Science started, was teaching our art friends like why they were getting drunk.
Because they are all dumb third graders.
Okay, we're gonna talk about this more because I'm obsessed. Okay.
But are we ending here?
Yeah, and I'm like, am I about to buy like a quantum computing book? No, that's crazy.
No,
I'm
it's
gonna do
not.
that. Well, it has to be like a Cole's Notes, like you know what I mean. I'm not gonna crack like. I have to figure out where one. Like,
and you're
we
right.
can
There's so
start.
many like because after reading Katie's MacBook, like that's quantum physics, right?
Yeah,
like,
yeah.
Talking about the end of the universe and
Yes.
talking about bosons and like how they like. So there are so many different probably like fields of this that no one.
We need Katie Mack to write the book about everything.
I mean, she kind of did. Okay, thank you for listening, and we'll see you guys next week.
Purse.
Bye.